Welcome guys. Today we are going to see the question C of Codeforces 629th round, which is division 3. So today we are going to see the problem ternary XOR. It's a quite simple problem, a kind of a linear problem which can be solved in big O of n. So let's go into the question straight away. So we are given a string consisting of only 0, 1 and 2. Okay, so we are given a very long number. Let's say it is x. The first, that is the leftmost digit, is always 2. So it's an important point to note. The digit always starts with 2. Now let's define the ternary XOR operation of two ternary numbers a and b as a number c equal to ai plus bi mod 3. Okay, so the result will always circulate around 0, 1 and 2. Since we are using modulo operation 3, the possible remainders are 0, 1 and 2. So the resultant will also be a ternary XOR number. It's quite obvious. Okay, now so we are given an example 10222 XOR 11021, which is 21210. Okay, now let's see this with an example. Let's say I'm having two numbers 21011 and 20001. Now observe that this is always fixed since the problem statement itself they have defined it, right? Okay, now 2 plus 2 mod 3 will give 1, 1 0 will give 1, 0 0 mod 3 will give 0, 1 0 mod 3 will give again 1, 1 plus 1 mod 3 will give 2. So it will be 1102, the final answer. Okay, so now what we are asked to do is we need to find two numbers a and b of length n without leading zeros such that maximum of AB is the minimum possible and A ternary XOR B must be equal to X. Okay, so let's see the given sample test case. They are given 22222 and the possible answer is 5 ones and 5 ones. Okay, now let's see 22222. Now what are all the possible answers for this? Okay, now let's say they are given answer as 1111 11111. If you take ternary XOR, it is obviously 1 1 plus 1 mod 3 is 2 2, everything is 2. So we are obtaining the result. Now if this is A, if this is B, maximum of A comma B equal to, let's say in this case it's either A or B. Let's say it is A. Now this is the smallest possible if we consider all pairs of possible solutions of A and B. See, it is not necessary that only this must be the solution. Okay, for example, if I am having 2 2 2 2, I can have solution like this also, right? 1 0 0 0 0 1 2 2 2 2. Now this will also give me the same exact result because 1 plus 1 mod 3 gives 2, 0 plus 2 mod gives 2, so similarly 2 2 2 2. But the maximum here is 1 2 2 2 2. Now if we go back, if we check, we have got 1 all ones here, but here we are getting 1 double 2 double 2. So when compared to these two, this is the minimum possible, so we need to display this AB pair. Okay, now how to approach the solution? The solution is quite straightforward actually. So Now let's find out what are all the possible options we have for a given remainder. Okay, for example, if x is, let's say, 2 0 1, now what are all the possible values of choosing two digits such that the ternary XOR of the ternary XOR of the two numbers gives the value 2. So what are those values? Let's divide it into columns. 2 1 0. Now here we have 2 as a remainder. Now what are the possible values? Obvious is 2 comma 0 and 1 comma 1, because 2 plus 0 mod 3 gives 2, 1 plus 1 mod 3 gives 2. There are no other possible ways than this. Now let's go for 1. For 1 it is 0 comma 1. Let's see any other possibility. 0 0 1 come, 0 2 1 come, 2 2, 2 2 is there, so we will go for 2 comma 2 also, because 2 plus 2 is 4, 4 mod 3 is again 1. Okay, so for 0 we will check. For 0 the only possible way is, no, actually there are two possible ways, 0 comma 0 and 1 comma 2, because 3 mod 3 is 0, so 1 plus 2 mod 3 is gives 0. Now we have 6 choices totally. Out of this we should pick one choice for then whatever remainder we are going to take. Okay, so sorry for that. Okay, now let's go for the solution. Let's say the solution is 2 1 0 1 1. This is the required x. Now let's apply our solution here. See, the first, let's say the string is s, and the string b is s1. The string a is s and the string b is s1 here. Now since the first is always 2, we can safely put 1 and 1 here, because neither of them affects the minimum possibility. Okay, both are equalized now. Now when we are going to 1 here, what are the possible way in which we can take 1? Let's go back and see. It's 0 1 and 2 2. Okay, it's 0 1 and 2 2. We don't want to put 2 2 here, because it increases the the maximum. Let's say it increases the maximumness of this number. It's quite obvious. For example, what I'm saying is, what are the possible ways? It's 0 1. Now if I put 0 1, this is somewhat minimum than putting 1 2 1 2, right? Because this this number is less than 1 2. You get my idea, right? So we will ignore the 2 2 case always for 1. It is always, we are going to only consider the pair 0 comma 1 for the remainder 1. Okay, now we are having 0 and 1. Now what we are going to do is, and obviously when 0 is encountering, we will always go for 0 comma 0 pair, because 0 doesn't affect any maximumness of the number. So for 0 it is always 0 comma 0. It is fixed, there's no question about it. Okay, now we are coming for 1 here. The same way we can do it, like probably what is the possible ways for 1? It is going to be 0 1 and 2 2. Now here let's analyze what if we choose two different possible pairs. The first one is 0 1 and second one is 2 2. So here if we choose 2 and 2, both are equalized, and still this remains the maximum one. But what if we choose 0 1 instead? We can choose 0 1, right? So let's go for 1 0. Now still the remainder is 1, and similarly we can apply this for here also. So this is the maximum possible value, and this will be the minimum among all possible values. Okay, the reason is very simple. See, the first one here, it is always fixed. The second one we are having 0 1, and once we have encountered a remainder 1, this is a very important point. Okay, once we have encountered let's say the first one, okay, we are iterating from 2, then from 1, then from 0 1 1. The first time when we are encountering a 1 here, we will put it as 0 1 normally, and for the next upcoming ones we will always put 1 0 in the reverse manner. The reason is very simple. Let's say, what's the example? 2 1 0 1 1, right? Okay, 2 1 0 1 1. I'm sorry for that, 1 1. Okay, now the obtained answer is no, let's go in order: 1 1 0 1 and 0 0. Now the reason why we are trying to reverse the order of 1 0 instead of 0 1 is, you just need to observe something here, because see, the moment when we appended 0 1, this is never going to contribute the maximum number. This is going to be the maximum number, right? So for the upcoming numbers, we can let's say this is x, this is y. Now for the upcoming numbers, x can take any maximum value, because that won't affect this whole number to be the maximum, right? Only this is going to be the maximum at last. So we can take x to be the maximum and y to be the most minimum, because that must be the optimal now, because we need the maximum to be minimum, right? So in this case, it's not going to be for 0 it is always 0 0. For 1 it's not going to be again 0 1, but instead it's going to be 1 and 0. So similarly it will go like this. And are there any more case? For example, what if another 2 comes? Now here we can't append 1 1. Let's check for another possibility. What are the two different ways for 2 pair? It's 2 0 1 1, right? So let's try for 2 0. That is the maximum. Let's take the maximum value to the minimum number of a and b and append 0 to the b. Let's be clear here. Instead of this, I am doing 2 and 0. See, here we are not forced to replace 1, but we can go for a better choice, 0. So now this will be the new minimum of those maximums. Okay, so the condition is very simple. Whenever you are encountering a 0, go for 0 0 pair. Whenever you are encountering a 2, go for 1 1 pair, or 0 2 0 pair. For 1, go for 0 1 or 1 0. Now these two cases will be possible only when a 1 is encountered earlier. So you can keep a flag variable, or else just let's keep it as f. Okay, now let the input be 2 1 0 1 1 2. Now for 2 it will be 1 1. For 1, for the first occurrence of 1, let it be 0 1, and set the flag to be 1 here. Okay, now for 0 it is default always 0 0. Now for 1 it is not 0 1 because the flag is on. So we are going to reverse it. It must be 1 0. Check the flag. If the flag is 1, reverse it. And for 2 it should not be 1 1 again because the flag is on. So we are going for 2 0. So that's it. So it's a big O of 2n solution maybe, which is we can call it as big O of n itself. So it's quite easy problem, nothing to think much about it. Just be greedy in your approach and set a flag and check the conditions, necessary conditions which are set. Okay, so that's it. Thank you for watching the video. Good luck.